Hello, everybody. Today we're presenting our next generation Mars Rover capstone project. We built this robot to compete in the University Rover Challenge, international robotics competition where universities from all around the world bring their robots to Hanksville, Utah to compete in four main missions. So there's a variety of constraints and guidelines for each robot to meet.
The arm of our rover has multiple different goals in mind. The main ones being to keep it lightweight, easy to control, and be able to autonomously type on a keyboard. We're doing this by implementing BLDC motors and string wave gearboxes on each of the joints. And for the software, we're implementing inverse kinematics as well as a computer vision to detect the keyboard, and the inverse kinematics is used to move the arm to the keys. We also created a custom test bench to test autonomous typing, and we have an equipment servicing rig which we can use to practice for the competition.
Our drivetrain is a tank tread system, which has to fully support the weight of the rover, dynamically move across uneven terrain, and be the minimum possible weight. We have a horizontal volute suspension system and a dynamic tensioner, which achieves this, and 3 kilowatt BLDC motors.
For autonomy, the robot's able to navigate to GNSS coordinates and do a search algorithm to look for objects of interest like an Aruka marker or other things we've trained it on. It does this with a variety of custom algorithms and an extended Kalman filter. Here's the flowchart for how it works. And for the chassis, we wanted something to bring in cool air and cool off the electronics. So we made a sheet metal body. And then we wanted to be able to remotely reset any circuit or any system on the rover in the event that it freezes or crashes. To do this, we designed a custom circuit board that can remotely set any relay on or off while also doing power management.
The science assay has a sleeved auger drilling system, which collects samples from 10 centimeters under the earth. This distributed to two different test apparatuses, the bioluminescence and the pyrolysis test. We have a custom GUI which controls the motors and transmits data to our sensors. We used a multivariable test to find the ideal heating element.
Here are our references and our sponsors. Thank you very much for listening.